In this section of the chapter, we're going to be dealing with multiplication and division of fractions. Now, the thing that you need to know that's different from adding and subtracting of fractions is if I'm adding and subtracting, I'm dealing with terms. If I'm multiplying, I already have factors. If we go straight into our first example, we can see by looking at the numerators and denominators that they are in fact separated by a times sign, which means that each numerator and each denominator is already a factor. But you can clearly see that nothing can be cancelled over here because you cannot cancel a part of a bracket factor with another part of a bracket factor. So I need to do a lot of factorizing so that I can try and find factors that match both from the numerator into the denominator so that I can cancel common factors and simplify the expression. Before I start, I want to make sure that all of my numerators and denominators have a perfect reducing degree of x. And you can see that the numerator of the second part does not have that. So changing it so that the x squared term comes first, I'm going to write it as follows. The first fraction can be written exactly as it was because it was perfectly in a reducing degree of x, as was its denominator. Taking out a minus, I can now write the x squared first, and taking out the minus, the plus 36 becomes a minus 36. And the denominator of the second part remains as it was because it was already written in a reducing degree of x. Now what I need to do is I need to start factorizing. When I factorize, I need to consider all the different types of factorizing I can do. I need to say, is there a highest common factor? Can I do a difference of two squares? Is there trinomial factorization? Is there a sum or difference of cubes? Or lastly, will I have to resort to grouping? In my first numerator, you can see that there is a highest common factor of 2x. Taking out the 2x, I have x cubed minus 1 left in the bracket. In the first denominator, there is a trinomial. Factorizing this trinomial, I'm going to get that I have x squared, I'm going to have x plus 6 and then x minus 1. Moving on to the next part, remember there's still a minus, but in the second numerator there is a difference of two squares, which gives me x plus 6 and x minus 6. And then going into the second denominator, I notice that once again I have a highest common factor of 4x. Taking out a 4x from each term, I have that I've got x squared in my first term, plus x in my second term, and then plus 1 in my last term. I've clearly not finished factorizing because my first numerator and my second denominator look as though they might be able to be factorized further. On closer inspection, I can see that the trinomial in the denominator cannot be factorized, so all I need to do is continue factorizing by doing a difference of cubes with the x cubed minus 1. When I factorize this difference of cubes, my first bracket comes out as x minus 1, and my second bracket is going to be x squared plus x plus 1. I'm now ready to try and cancel common factors. The first common factor that I can see is this nice long trinomial bracket, and I can cancel the one on the left at the top with the one on the right at the bottom. The x plus 6 factor is repeated. The x minus 1 factor is repeated. The x factor is repeated. And 2 can go into 4 twice. Now writing down my leftover factors, I have a simplified fraction. In my numerator, I only have a minus x minus 6 left over, and in my denominator, I have a 2. So fully simplified, my answer is going to be minus x plus 6 all over 2.